All right, tomorrow we have the last quiz of the quarter. What kind of quiz do we have? Is it a 40 or a 50 pointer? What the heck, let's take a 50. And you'll get, how many free points do you want? Okay, 10 it is then. 50. That's ridiculous. Anyway, tomorrow's quiz is basically antiderivatives. So today's lesson, we start chapter 7 today. If you look at the title of it, the title of chapter 7, I believe, is Differential Equations. What the heck is a differential equation? Well, a differential equation is an equation that has a derivative in it. Okay, so let's look at a simple one. dy dx is equal to x squared. Why don't we do it this way? How about 3x squared plus 4x plus 5? This is a differential equation because it has a derivative in it. Anyway, how do you solve this differential equation? Well, if this is the derivative of some function, what was the original function? How do you think you're going to find it? You find the antiderivative, right? So what function do you take the derivative of to get this? So in other words, you got to know how derivatives work in order to find the antiderivative. So what? Come on, we got to remember something. What do I take the derivative of to get this? X to the third power, right? Because when you take the derivative of this, you get 3x squared. Plus, what about this term? 2x squared. What about that term? 5x, right? The derivative of 5x is 5. And then don't forget to put the plus c. Right? Because c can be any constant, right? Because, like, for example, if this was a 1, the derivative of 1 would be 0. Or it could be negative 2. The derivative of negative 2 is 0. You don't know what that constant is, so you put a plus c. And every antiderivative must have a plus c. So on tomorrow's quiz, if you don't put the plus c, that's an automatic minus 1. So see how this is an easy one because it's a polynomial, but then you know I'm going to test you on all your antiderivatives, right? So here, I think we better do some more. Dy dx is equal to, okay, let's think of some that we haven't seen for a while. How about 1 over 1 plus x squared plus cosecant squared x plus sine x plus 1 over x cubed. So if this is the derivative of a function, what was the original function? Okay, look at that one. That is the derivative of tan inverse x. And then what about this one? Negative or positive? Negative cotangent x, because remember, the derivative of cotangent x is negative cosecant squared. So if you are befuddled, what do you need to do tonight? You got to look at the derivative list. Anyway, come on. This is calculus. Basically, what is calculus? Just derivatives and integrals. That's all it is. What about this? Negative cosine x. Because the derivative of cosine is negative sine. And then what about this one? Now, you might want to rewrite that as x to the negative 3. So when you take the antiderivative, what has to happen? The power got to be 1 bigger. So negative 2, and then you need to put the reciprocal in the front, so when you drop it down, it cancels out. What's the reciprocal of negative 2? Negative 1/2. And then of course, how can you check this? If you take the derivative of each term, you should get all of these things. So is that your answer? Box that, that's the answer. No, that would be a -1 plus C. So tomorrow, if you look at your homework tonight, basically there's 3 parts to the homework. This is the first part here. So each one of these is going to be 2 points, so 2, 2, 2, and then 1. So that's like 7 points right there. 2, 2, 2, 2, 1. Okay, let's do another one. dy dx equals, because some of you haven't even looked at a derivative for I don't know how long. 1 over square root of 1 minus x squared plus, what haven't we seen in a long time? 5 to the x. Oh, how about e to the x then, for that matter? And then how about 1 over x? There. Now let's go 1 over cube root of x. Let's do that. All right. What was the original function then? What do I take the derivative of to get this? Sine inverse x. What about this one? All of these were on the last test, but then, you know, those 3 weeks ago. Okay, if you're unsure, how about think of the derivative? Okay, so here, what if you had y equal 3 to the x power? What would the derivative be? How do you take the derivative of 3 to the x? 3 to the x times natural log 3. So what would be the antiderivative of this thing? 5 to the x divided by natural log 5. Right? Because when you take the derivative of this is a constant, so you throw it on the side, and the derivative of 5 to the, here, throw it on the side, and the derivative of 5 to the x is 5 to the x times natural log 5. See how the natural log 5's cancel off? You guys did it on the last test, remember, almost everybody got it. Okay, moving on. What's the derivative of e to the x? E to the x, that one's simple. I mean the antiderivative. And then what about this? This is the same thing as x to the -1/3. So that means I gotta make the power 1 bigger. So x to the 2/3, and then you put the reciprocal in the front, because then when you drop the 2/3 in the front, you need something to cancel it out. Box that, that's the answer. Don't be ridiculous, don't forget the plus c. Are we getting the hang of it? Okay. We're going to do a little bit more before we do the harder ones. These are just the basic ones that are on the list. dy dx is equal, okay, what are some other ones we haven't seen? How about secant x, tangent x, we haven't seen that one for a while, plus 1 over x. How about plus 1 over x squared? And what's another one we haven't seen for that might cover almost all of them. Okay, let's just go with that. So what was the original function? Secant x, right? The derivative of secant x is secant x tangent x plus 1 over x. Okay, somebody remembered something. Natural log x. Now that's the way we did it last chapter, okay? The derivative of natural log x is 1 over x. However, now we're going to be even more correct. Starting from today, the antiderivative of 1 over x is not just natural log x, because that's not completely correct. It's natural log absolute value of x. How come you need the absolute value? Because what is the domain of this function? All real numbers except 0. Okay, now, if you didn't have the absolute value there, what would be the domain of this function? Remember, when you have natural log, this thing has to be greater than 0. So it doesn't match, the domains don't match. So to make the domains match, you need absolute value there. Because now, what is the domain of this function? All real numbers except 0, that's right, natural log 0 is undefined, that's why, right? So that's why you need the absolute value there. So if you don't put that absolute value, that's minus 1 for now. But as we go on, it's going to be minus 2. What about this one? This is the same thing as x to the negative 2 power. So what do? You make the power 1 bigger, negative 1, and then put the reciprocal in the front, minus the 1, and then don't forget to put the plus c. Mr. Park, how come we can't do it for this one? How come we can't just go x to the negative 1, so just make the power 1 bigger, 0, and then put the reciprocal in the front. That's why you can't do it, because 1 over 0 is undefined. Yeah, you can change it to x to the negative 1, but still the antiderivative is going to be natural log absolute value of x. Okay, so those are the basic ones, okay? But then tonight's homework, you get more difficult ones as well. You're going to get the easy ones, but you're going to get more difficult ones as well. Okay, so here we go. dy dx equals, okay, let me think, e to the 3x plus cosine 2x plus, how about x plus x squared plus x plus 1 all over x squared. Okay, how about something like that? Okay, what was the original function? What do I take the derivative of to get this? In other words, what's the antiderivative of that? Is it just e to the 3x? No, because I left the space in the front for something. Yeah? And what is that something? We talked about this before. 1/3. Why do you need a 1/3? Because the derivative of e to the 3x, is it just e to the 3x? No, because then you gotta times it by the derivative of the box, which is 3. So that's why you need that 1/3 there to cancel out the 3. So now you got to start thinking about the derivative of the box, because the derivative of the box, see, like these, the derivative of the box is all 1, so it's easy to figure out. But then, is it always going to be 1? And the answer is no. Okay, what about this one? What's the antiderivative of cosine 2x? Is it just sine 2x? No, because I left the space for the 1/2 there. Because the derivative of sine 2x is cosine 2x times the derivative of box, which is 2. That's why you need that 1/2 to cancel out that 2. You guys get it? Yeah, we did this before. We just had vacation was too long. And then what about this thing? What do you do with this? Very good. So you guys remember something. Lift and separate. Anytime you see a single term in the denominator, you lift and separate. So this is the same thing as what? What is x squared over x squared? 1. What is x over x squared? 1 over x. And then what is 1 over x squared? 1 over x squared. Okay, so just take the antiderivative term by term. What's the antiderivative of 1? X. What about this one? Natural log x? Absolute value of x. And then what about this one? We already did this one somewhere. Oh, it's right there. This is the same thing as x to the negative 2. So you make the power 1 bigger, put the reciprocal in the front, and then don't forget the plus c. Oh, that's not that bad, Mr. Park. Yeah, except tonight's homework, the book has even harder ones. What are you talking about, Moose Prep? Now, tomorrow I'm probably only going to give you one of these. Okay? So dy dx is equal to, okay, I'm trying to think what's in there. How about sine to the 5th x times cosine x? I'm just going to give you one. Because it's not that easy to think of. Now remember, anytime you have a trig function to a power, maybe you might want to write it like this to help you think about it. All right, so what do I have to take the derivative of to get this? Or what is the antiderivative? buddy? You gotta know how, see, in order to find the antiderivative, you gotta know how derivatives work. Should I just tell you the answer and then you do it, okay? It would be 1/6 sine x to the 6th power plus c. What? Well, let me ask you this. If I take the derivative of this, would you get that? Well, let's try. This 1/6 is a constant, so you throw it on the side like an unwanted back. Yeah. Now, what do I have here? A box to the 6. How do you take the derivative of box to the 6? 6 box to the 5th times the derivative of box, which is cosine x. Is that the same thing as that? Yeah, because see, the 1/6 cancels the 6, and then you got that. See, now you gotta think of the derivative. See, like these problems, the derivative of the box is a constant. That's kind of easy to figure out. But what happens when the derivative of the box is not a constant? It's like another function, and you gotta think even harder. Okay, let's do one more of those then. dy dx is equal to secant squared x e to the tangent x. What was the original function or the antiderivative? See, this first section, 7.1, these are considered like easy antiderivatives. Then, not these kinds here, these are a little bit harder. And then we're going to do even harder ones. There you go. E to the tan x plus c. What? Well, all you got to do is ask yourself, if I take the derivative of this, will I get this? Well, what's the derivative of e to the box? Is it just e to the box? Okay, good. No. Then you got to times it by the derivative of the box, which is secant squared x. And of course, the derivative of a constant is 0. So, yes, this is the same thing as that. That's the antiderivative. I'm only going to give you one of those tomorrow, because it's hard. Mr. Park, what if I can't think like that? And that's why we're going to do 7.2. That's why the next test only covers 7.1 and 7.2. You know, that's it. Actually, though, I think you guys should refresh your assignment sheet because I actually changed the assignment sheet. So 7.1, we're actually going to spend 2 nights on it because it has 2 things. So we're not going to even get to 7.2 till next time. So not tomorrow. Anyway, okay, so the first section of tonight's homework is just this. Okay, what is the second section? I'm going to erase. Basically, it's the same thing, except, let me just write it down. So basically what's going to happen tomorrow, I'll give you guys like 10 minutes to ask questions. Don't think you're going to write all the even problems, because basically I assign all the problems now. There's a lot of even ones. Don't think you're just going to write the even ones down. I don't know if we have, well, maybe we can. I can just write the answers if you want. Did you ever find that Chinese website that has all the answers? Okay, the second part of tonight's homework are problems like these. The dy, it's the same thing. It's a differential equation. Give me something here. How about 2x cubed plus 3x squared plus 4x plus 5, but they give you this other thing here, like y of 0 is equal to 4. No, 6. Let's use numbers we haven't used before. Now, what the heck is, Mr. Park, I understand what this is. This is the differential equation we've been doing. But what is this? This is called an initial condition. Okay, so basically what you do is you just do this problem like you normally do it. If you know the derivative, how do you find the original function? We've just been doing it for the last 15 minutes. You take the antiderivative. Okay, what's the antiderivative of this? Make the power 1 bigger. You see, polynomials are the easiest functions you have, people. Make the power 1 bigger. 4, and then what do I have to put in the front here? So when I put the 4 down in front, you get a 2. 1/2. There you go. That's all you gotta do. Okay, next one. Okay, let's again calling people Chung. Okay, next term, Chong. There's no Chong, is there? Lee. Kavika Lee.
2x cubed. Squared.
See, so you guys can do it. Next one, other Lee.
5x.
Box that, that's the answer. No, the plus C. So, Mr. Bart, what do you do with this initial condition? I think you guys can figure it out. Yeah, you plug it in, and then what do you think is going to happen? You're going to compute the value of C, exactly. So if you are given an initial condition, you can figure out the exact value of C, and that's what we use it for. So all you have to do is, when x is 0, y is 6. Just plug it in. So if you plug in 0 for x and 6 for y, we can figure out what C is. So do it, plug it in. 6 equals 0 plus 0 plus 0 plus 0 plus C. We just figured out that C is 6. So that means the solution to this differential equation with this initial condition is y equals 1/2 x to the 4 plus x cubed plus 2x squared plus 5x plus 6. In other words, if you take the derivative of this, you will get that. And as well, if you plug in 0 for x, you will get 6. So this is called the solution to the differential equation. Okay, that's an easy one. Let's do one more. Dy dx is equal to, let's put some challenging ones here. How about, I just had 1 over root x plus sine of pi x plus x. No, that's too easy. Yeah, let's go to root x. And initial condition, y of 4 is equal to 1. Okay, so here we go. What is the original function? Take the antiderivative. What's the antiderivative of this now? This is like x to the negative half. So you make the power 1 bigger. X to the half. Put the reciprocal in the front. Okay, now what about this? What's the antiderivative of sine pi x? Is it just negative cosine pi x? No, because I left the space in the front. And what should go in that space? 1 over pi. Because look, the derivative of the box is pi. You need a 1 over pi to cancel that out. Just like you had 2x there, you put a 1/2 in the front. Same thing. And then what about this one? That's the same thing as x to the half. So you make the power 1 bigger. And then you got to put the reciprocal in the front. 2/3 plus c. Okay, so we got this. What do we use the initial condition for? To figure out the value of c. So that means if I plug in 4 for x, the y value should come out to 1. So all you got to do is plug in chunk now. 1 equals, what happens when I plug in 4 here? 4 minus, plug in 4 here. Cosine of 4 pi is 1, right? Because cosine of 2 pi is 1. Cosine of 0 is 1. So 1 over pi. Why do we have problems with trig values? We just do. And that's a quadrantal angle. Plug in 4 here. 4 to the 3 halves. 8 times 2/3. 16/3 plus c. Can I figure out the value of c? You bet your sweet bimpy you can. So c is equal to, here I'll just do this for you since you guys are rusty. 1 minus 4 plus 1 over pi minus 16/3. You gotta simplify that. What is 1 minus 4? Negative 3, which is negative 9/3. So you get 1 over pi, and what is negative 9/3 minus 16/3? Minus 25/3. There, that's the value of c. Sometimes it's just not nice. So what is the solution to this differential equation? Y equals 2x to the half minus 1 over pi cosine pi x plus 2/3 x to the 3 halves plus c. But now we know what the value of c is. It's 1 over pi minus 25/3. All right, so the second part of tonight's homework is problems just like this. You get the differential equation, but then they give you an initial condition, and all you do is you use that to figure out the value of c. It's not that difficult. And the last part of tonight's homework, we actually did problems like this before, but I'm sure you forgot, so I'm going to erase this. Maybe I should just, I was going to say, we should just do the homework problems. No, you guys got to do the homework problems. dy dx is equal to, okay, let me think of something. Hey, cosine of x squared, initial condition, y of 1 is equal to 2. There you go. Now the directions in the book says, it gives you a hint, and I'll probably give you that same hint tomorrow. It says, it's going to say, use the fundamental theorem of calculus to solve this differential equation. It's actually the fundamental theorem of calculus part 1. We actually did this on a previous homework. Now, can I just look at this and figure out what the antiderivative of this is? Can I go, oh, this is cosine box, so the antiderivative should be sine box. But what's the derivative of the box? What's the derivative of the box? 2x, so can I just go over 2x then? Plus, and then put plus c? Does that work? If I take the derivative of this, will I get that? And the answer is no, you cannot do that. Why doesn't this work? Because if you take the derivative of this, you cannot, see, this is not a constant. You cannot just throw it on the side like an unwanted pet. You would have to use the quotient rule on this to take the derivative, and I guarantee you, if you use the quotient rule, it ain't gonna look nice like that, right? You guys remember the quotient rule? Low D high minus high D low over denominator squared we go. So no, you can't. So that is why the only way you can do this problem is you gotta use the fundamental theorem of calculus part 1. Do we have to review the fundamental theorem of calculus part 1? I think we do, because otherwise you can't do it. Okay, let's review it. If you are given a function that's defined as an integral, do you remember? And if the lower limit is a constant, remember how you use the fundamental, the lower limit got to be a constant, and then let's go here, tan x over here, and then you got like the square root of 1 plus t squared dt. How do you take the derivative of a function that's an integral like this? Remember? What's the first step? You make sure the lower limit is a constant. Check. Then what do? You take this upper limit and you plug it in for t there. So you get the square root of 1 plus tangent t squared. And then the most important part of the fundamental theorem of calculus part 1, then you got to multiply it by the derivative of that, which is secant squared x. That's the fundamental theorem of calculus part 1. Now is it coming back like a bad dream? That's the part that's not, I don't even recognize the stream. Come on! Okay, so now that we reviewed that, what do I need to put here so that when I take, okay, I'll give you a hint, it's going to be an integral. What should the lower limit be? It can be any constant, it can be any number, it can be 0, it can be 1, it can be -1, it can be 5, it can be 5 pi, whatever.
1.
Yeah, it's going to be 1. Why 1? Because of that. Now some of you are going, what are you talking about, Moose Brett? Well, why don't we just finish this so you can see. What do I put on the top here? X. Because that's easy, because the derivative, remember you got to multiply it by the derivative of this, that's why. So if that's an x, you're just going to multiply it by 1. The derivative of x is 1. And then, what will go here? Cosine t squared dt. Because look, if I plug in the x right there, don't you get this? And that's what you want. Remember, you're plugging that thing into here, right? So if I plug in this x into there, don't you get that? And then you gotta multiply it by the derivative of that, which is just 1. So yeah, that works. But the initial condition says y of 1 has to equal 2. So now do you see why this is a 1? Because what happens when I plug in 1 for x here? What is the integral from 1 to 1? It's 0. So what number has to go in the front there so that if I plug in 1, you get 2? Yeah, you put a 2 there. Now some of you are going, what the heck is he doing? Look, if I plug in 1 for x right there, the integral from 1 to 1 is 0. 0 plus 2 gives you the 2. That's why whatever number is here, that's what you put on the bottom there. I think we better do another one. Someone can, what you talking about? And I'm only going to give you one of these tomorrow because it's not that easy. But if you remember the fundamental theorem of calculus, you can. Okay, here we go. dy dx is, okay, I got to think of something that you can't find the derivative of. How about e to the cosine x? No, we already used the cosine. Let's do a sine x then. Initial condition. Y of 3 is equal to, give me a number. 4. Okay? Okay. What was the original function? Can you find the antiderivative? Okay, I'll tell you on this section here, you won't be able to find the antiderivative of this just using normal methods. You have to use the fundamental theorem of calculus. I'll put that in the directions. So what do you start with? Integral from 3. How come I put 3 there? Because that's what you did over here. That's right. Okay, and then what do I put on the top? X. So then what goes here? E to the sine t dt. Right? Because when you take the derivative of this, you're going to plug in the x right there. That's how you get e to the sine x. Times the derivative of that, which is 1. But it says y of 3 is equal to 4. So what number goes in over here? 4. Because when you plug in 3 here, the integral from 3 to 3 is 0. 0 plus 4. 0 plus 4 gives you 4. So actually, this is actually way easier than the other problems because you don't have to know any antiderivatives. All right, so you know the format of, so here, take out your book there. Take out your book and then let's look at there's basically only 3 things you got to do for tomorrow. It's so easy if you know your antiderivatives. So if you look at your book, look, problems 1 through 10, right there. I think I made 4 of those problems. But it's actually more because I just, whatever. And then 11 through 20, that's the kind with the initial conditions. And then finally 21 through 24, that's these problems here. And that's all it's going to cover. But there's actually more, but we're going to save that for next time. So tomorrow's quiz should not be difficult if you know your antiderivatives. So what can you do to get reacquainted with your antiderivatives? Do the homework. That's what you should do. Okay, we are done. What time is this period end? 40, 35, 45. Okay, we got 30. We're gonna watch the movie because we're gonna continue the movie. You guys even remember where we left off? Because I don't. So what? Did we do give her the chair, man?
Yeah.
Okay, we passed that. Did he go to the restaurant?
No.
Because didn't Anna leave school
Oh, yeah.
and she worked in the family restaurant?
Wait.
He was walking to a car. I remember that.
Oh yeah, his car got broken into.
Oh, they took the radio from his car.
Yeah. Oh, okay.
Okay, I have nothing. We'll just go scene by scene.
I'm going next period.
What do you do?
I didn't realize how stupid.
Oh, wait, we gotta stop the video.